Good morning, everyone. I would like to welcome the next speaker, คุณกันกมลพัฒน์ คุณกันกมลพัฒน์ Are you ready?
Yes.
Okay. คุณกันกมลพัฒน์ Sanguanchaiyakit from King Mongkut University, Thonburi, Bangkok. Today, she will talk under the topic of development of virus-like particles-based oral vaccine against canine parvovirus. During her presentation, if anyone has question, you can type in chat box. Okay. And คุณกันกมลพัฒน์ will be answer at the end of presentation. Please welcome คุณกันกมลพัฒน์ Sanguanchaiyakit. คุณกันกมลพัฒน์ please.
Okay. First of all, I would like to say sorry to all Ajahn because I have some problem with my computer, so I cannot join this conference in time. Okay, so from now on, I would like to present my work in the title of development of virus-like particle-based oral vaccine against canine parvovirus. Okay. ทำไมถึง Okay. Canine parvovirus or CPV is a contagious virus in the family of Parvoviridae. CPV is a non-enveloped virus containing DNA as genetic material, and they use the capsid protein called VP2 that play important role for virus infection. The canine parvovirus type 2 is leading cause of morbidity and mortality in dogs globally. And they evolve into 3 variant strains, which are CPV2, 2A, 2B, and 2C. This infection is also known as parvo disease, which can be found in dog of age and breed. Especially unvaccinated dog and puppy is susceptible for this infection. Parvo disease symptoms are vomiting, hemorrhagic diarrhea, anorexia, and sudden death. So to prevent this disease, dogs must be vaccinated. Commercial available vaccine in the market are live attenuated and inactivated vaccine. However, there are some concerns over these vaccines such as risk for virus mutation and conversion to variant strain of live attenuated vaccine, insufficient chemical inactivation or immunogenicity change due to chemical inactivation vaccine, and multiple doses may be required. So the newer vaccine candidates containing safe and high potential antigen are in need. Moreover, the convenient and painless administration is of interest since the vaccine should be given to puppy at very young age. One of the vaccines that can overcome those current vaccine problems is vaccine made from VLP. What is VLP? VLP is virus-like particle structure formed by viral protein but contain no viral genome. Therefore, they are non-infectious. VLP can represent antigen in a dense, repetitive manner, thus effectively enabling the cross-linking with B cell receptor and enhance immune stimulation. VLP can be naturally occurring or synthesized through the individual expressions of viral structure protein, which can be cell-assembled into virus-like structure. In this study, insect cell expression system was used. In addition to the new antigen, a new adjuvant was also proposed for formulation of a painless and convenient oral vaccine. This new adjuvant is bacterium-like particle or BLP. BLP is made from lactic acid bacteria, which has GRAS status. And how can we make BLP? The lactic acid bacteria was treated in the hot acid to get rid of the bacterial genome and washed with a buffer to eliminate remaining acid. Peptidoglycan, which is the bacterial cell wall that specifically recognized by immune cell and therefore stimulate better immune response. BLP also have cell wall hydrolase called ACMA, which is the binding domain that can bind to VLP antigen as shown in the cartoon picture. Moreover, this adjuvant is well-defined mode of action on activation of innate receptor. As previously described, our objective therefore are to develop canine parvovirus-like particle from canine parvovirus VP2 protein using baculovirus insect cell expression system. Second is to prepare oral vaccine adjuvant, which is bacterium-like particle from Lactococcus lactis, and to formulate VP2 VLP-based oral vaccine against canine parvovirus. My flow work divided into two parts. The first one is VP2 gene expression and VP2 analysis. VP2 recombinant PFAS bag containing VP2 gene was constructed and used as donor plasmid for transfer into SF9 cell. And VP2 protein was analyzed by Western blot analysis with the specific antibody with VP2 protein and HA assay, together with characterization of virus-like particle under transmission electron microscope. The second part is oral vaccine preparation. VLP is made from Lactococcus lactis that treated with a hot acid and washed with a buffer to get rid of the acid, and then make it by directly. Let's start to the first part, in which VLP are produced in baculovirus expression system to produce an antigen for our oral vaccine formulation. First, VP2 gene was inserted into PFAS bag vector at the transposition site and then transformed into E. coli detection bag that contain baculovirus genome. And then we extract the plasmid and transfect into insect cell. Finally, we will get recombinant baculovirus containing VP2 gene and infect the recombinant baculovirus containing VP2 gene into the insect cell again. For VP2 gene expression system, RT-PCR was used, and the results show that infected SF9 cell obtain recombinant VP2 baculovirus from the infection. For SDS page and Western blot analysis, what used to confirm protein expression showed the size of VP2 protein is around 76 kilodalton, and was confirmed with another method, which is HA assay, because of VP2 has characteristic to react with the red blood cell. So the results show that infected recombinant baculovirus containing VP2 gene can react with the red blood cell as shown in the row A. Together with to see the formation of virus-like particle, we visualize under transmission electron microscope. The electron micrograph show that the virus-like particle of VP2 have size around 50 nanometer. For the first part, I can conclude that recombinant VP2 protein was successfully produced by baculovirus vector insect cell expression system, and recombinant VP2 protein has similar heme agglutination activity to CPV virus. The last one is recombinant VP2 protein could cell assembly into the virus parvovirus-like particles. Let's move to the second part. It's preparation of bacterium-like particle from Lactococcus lactis as adjuvant and formation of VLP VP2 VLP antigen. To make VLP, the culture medium of Lactococcus lactis was harvested by centrifugation and then boiled into the hot acid. We use 10% TCA. After that, we wash in the buffer. And then we have report that the particle under transmission microscope compare between Lactococcus lactis cell and bacterium-like particle. The bacterium-like particle show the clearer picture than the Lactococcus lactis cell. So from now on, I would like to show the binding of VLP to VP2 VLP was also demonstrated by immunofluorescence staining. The Lactococcus lactis were seen in the bright field but cannot detect with CY3 filter that used for fluorochrome 594 detection. The fluorescent signal was only seen on VLP, which is the presence of VLP VP2 that bound by the anti-VP2 antibody and detected by fluorescence. From the result, show VP2 VLP was successfully linked onto VLP. So in the second part, I can conclude that Lactococcus lactis could be prepared as bacterium-like particle, and VP2-VLP BLP complex could be formed and will be further studied for its suitability as an antigen for Canine Parvovirus oral vaccine. And now this vaccine is now being tested for its immune stimulation efficacy, and in the future work, we will immunize into the animals such as we immune in the mice via oral administration and challenge with the natural Canine Parvovirus, and we will observe the mortality. Okay. Before we go, I would like to acknowledge my thesis advisor, Assistant Professor Dr. Kanukwan Phumpusa for her guidance to complete experiment. Yes. Thank you for your attention.
So I'm the one of dog lover. It's really interesting presentation. So we will have time for one or two questions. Any question? Okay, I will have one question. Okay. Is there any report using peptidoglycan hydrolase ACMA in other bacteria? Or
Yes, also have.
For example, in okay. In bacteria, which is the kind of bacteria?
Actually, when I read the paper, they said that almost all bacteria in the group of gram-positive bacteria almost have this binding domain. Yes, but in this study, we choose Lactococcus lactis because we have GRAS status that might be fit for oral vaccine.
Okay, and one question in TM figure 6, in figure 6, okay, some artifacts or other particles may be generally observed. So how do you convince that this image are parvovirus-like particle?
Actually, you are correct that have another contaminant, but we observe many fields in under transmission microscope, and in many fields they show that the micrograph allow 50 nanometer have much enough to conclude that it is parvovirus-like particle, and before we go to the TEM, we analyze and confirm by Western blot analysis as well. So maybe the amount of that particle can assume that it is parvovirus-like particles.
Oh, any question from chat box?
Okay. We have one question from Dr. Walanju, please.
Okay.
Dr. Walanju.
Thank you very much for the very nice presentation. I just would like to ask, what is the yield of the VLP that you get from your insect cell expression?
The yield. Now we just only culture in the small scale, not in the large scale. So maybe.
But at least, like, if you plan to do if you plan to do immunize in the animal in the future, then you should know like the yield, approximate yield, and then you can know like how much you have to prepare, right?
Yes, maybe in the long step, because of now in the process we are, as I told you before, now we are testing in the animal, and we will calculate about the amount between the antigen and BLP as well, and how can they respond in the how their immune response, because of now we done in the injection in the chicken as well, but the result didn't show yet because of we just collect the egg and didn't taste another experiment because of this pandemic. So sorry, I cannot tell you.
When you prepare the VLP from the cells, like let's say you have like 100 ml of the media, right? Let's say like all those small scale, but how much VLP, like nanogram, microgram, milligram, like approximately that you get?
Actually, after we culture the bacteria, right? We read the report. The paper report that we can use around 1 unit of VLP, which is around 2.5 times 10 power 9 cell of VLP. Yes, that is enough for oral vaccine. So this time we try to use 1 unit of VLP and mix with the VLP directly and inject into an animal.
I see. Another question is like when you do TEM, that picture that you get, is that from the? Do you have to purify VLP before taking the using it for TEM, or you just use the crude?
Actually, no. We are purified before like sucrose gradient before to go to TEM.
I see. Thank you.
Thank you.
So because they run out of time, so thank you very much, Kun Kankamonpat Sanguanchaiyakit, for your presentation. On behalf of everyone here, I would like to thank you for the most interesting presentation. Thank you, Kun Kankamonpat, again. Okay.